as we change the stride. Now, but you have to ask, and you probably can infer this qualitatively by looking at your training set. Will you lose important features by striding by 2, by striding by 3? It depends on the quality of your training data.
By the way,
Awesome,
I think
thank you.
even with the stride one at the end, it will be, yes, it's the training will be a little bit slower, but he will lose something unless he use padding. So at that time, you are sometimes you need to use padding for some cases. Now today we suppose, Tom, if there is anything to add, or should I start, or you have something to share? By the way, I'm ready with something, but if you okay. Today we have to, it's supposed to host Mr. Sadiq Mohammadi, but in fact he asked us to postpone it to next week. So I will continue with the same example. I'm going to speak about the data augmentation. With there's nice things we will see, and also there is some assignment it will be at the end of the session. I'm preparing again for the next week for data balancing by Sadiq. Okay, so I will share my screen now. And sorry if we start late because I'm just finishing my dinner. Sorry for that. Okay. Now, since we are talking about deep learning scenario, so we are expecting that, and in image processing, especially in image processing, we are expecting a lot of data. So one of the techniques that used for data in deep learning scenario is the data augmenting or data augmentation. This is the first session about that. There is another session will be added after Sadiq's session about data balancing to see how to implement all of this. First, why we need data augmentation? What is data augmentation? It's a technique used to generate more data and add it to the data set to allow us to use deep neural network, to allow us to use deep neural network with a good amount of data that we need. Most commonly, it's used for computer vision tasks. Mainly, it's only computer vision tasks. I didn't see data augmentation in something else. Okay, but why it's needed? This is the important question. It's needed because deep learning concept, it's building on the data quantity that we need huge data set or good amount of data that help us to extract all the needed feature to make a decision, and also a huge number of data processing station. Data processing station, it's something that just I mine this, let's say this term right now, which is when we are talking about neurons or conv layers or fully connected layers, each one we can consider it as data processing station. In deep neural network or deep learning, we have a lot of these data processing stations. So with the huge data, we are pretty sure that we will get the, let's say, the suitable result that we are looking for. Now, at the end, data augmentation is used for increasing the data set size, and sometimes it's used for just like resampling, because it will help us to balance the data if the data is imbalanced. How to balance the data in this case? Just let's consider we have a classification task with 2 final classes we are expecting. For example, in our case, it's infected or non-infected with malaria, or in other cases, whatever. We have 2 classes, but in our data set, we have a lot of information for the healthy, for example, blood cells, and we have a less amount of pictures that describing the infected blood cells. In this case, we can use data augmentation technique to resample. Resampling, that means adding the same image with the same information, the same feature, just to the data set to make the data balanced. Now, if we use data augmentation, we are, let's say, adding more value to this data balance. So at the end, data augmentation, it's applying distortions on the current data to generate new samples and to add them to the data set. This is what is data augmentation. Right now, we are going to discuss about or to speak about the technicalities used there. What kind of data augmentation we are using. The first one, since we are talking about the image processing, we are talking about mirroring. Mirroring, it's a kind of just flipping the image horizontally, just to get the new image, which is most probably it will be the same class. That, for example, we have a cat here. If we are looking for animals classification task, the mirroring it will keep the same. And mirroring it can be happened on both sides. That means horizontally from left to right, or vertically from up to down. Now, in TensorFlow, we have in the image, in the class image, we have two methods will help us to make the flipping, which is flip left, right, and we pass the image, and at the end, the result will be the, let's say, the flipped or the mirroring image, or random flip left, right, random. What's here? What will happen with using random? This method, sometimes it will not make the mirroring. That means we are passing the full data set to the random flip left, right, and as a result, some of the image will be mirrored, and some of them it will not be mirrored, and it will be a random decision. According to that, we are sure that we are somehow make augmentation for 50% of the data set size. So most of the time we are using random unless we know where we need to make the mirroring. So we will use the flip left, right. This is in TensorFlow. But what is the concept? How this mirroring is happening? Now, this matrix here, let's consider it as a, let's say, one channel of image. So for one channel of image, that means for the red channel or green channel or blue channel, let's consider that the size, it's n by k. This is our matrix. To make the flipping, we have to make a loop. Let's say we are doing horizontal flipping. By the way, sorry, something I have to add. Here, another method to make the vertical flipping is flipping up down. It's also the same. We can use it in TensorFlow to help us to make the vertical flipping or the vertical mirror. How it's happened? We have, according to this picture, we have n by k matrix, which is our n. Now, we will create a loop when we need a horizontal mirroring. We will create a loop for half or n divided by 2 of the x axis, which is the n. For that means we start from 0 to n divided by 2. Now, we have to flip let's say, to make exchange in the values of the pixels. So the pixel x value, it will go to the pixel n minus x. And then when we make increment to the x, that means it will go to the previous one. For example, for x equal to 1. So this value here has to go there to the n minus 1. When x is 2, the value here it will go to the n minus 2. And the same, that means the value in n minus x, it has to go to the x. In this way, we are sure that we are making the flipping on the correct way. For sure, in any programming language, if we want to make this one by one, we need to use a buffer. So here we have a kind of pseudocode to tell us how to make that. We will store the x, the pixel x value in buffer, and then assign it to the n minus x, and then make the n minus x equal to the buffer value. In this way, we are sure that we make the horizontal flip. The same, it will be used for the 3 channels that we have, for the red, for the blue, for the green, for the blue. And at the end, the full image, it will be this. We're just changing the direction. We are not following the x-axis, we are following the y-axis. So, but at the end, it's the same process, 100%. Now, the same process, it can use for something else, which is the rotation. But before rotation, we have another technique might be used. By the way, I'm unable to read the chat while presenting. So if there is any question, Tom, Jonathan, or Gio, please, you can interrupt me and
Yes.
ask them.
Real quick, there was one Yahoo that's had his hand up for a while. His name's Tom. And I think you were just getting to it. I would have thought, yes, mirroring's important, but do we also want some rotation? Or do we find that the data set has the images rotated enough naturally that we don't need to rotate?
Now, Tom, for today, I'm just mentioning the most popular techniques used for the data augmentation. One of them is the rotation. And for example, if we want to make a rotation, we will use also, I'm mentioning here everything related to TensorFlow. But why I explain the mirroring, because it will help for the assignment. So that's why I explain it somehow in detail.
No, that's perfect. So basically, it's not that you wouldn't do some rotating also. You're just showing some examples of ways we make sure the data set's very thorough, so the neural networks or the convolutional neural networks getting trained on the features being in different orientations, basically.
Exactly. But sometimes we are unable. We will discuss about that just when we finish. We'll discuss sometimes that this kind of data augmentation, it will not help. So again, it's depending on the data that we have and on the task nature that we have. Now, the second method, it's the random cropping. The random cropping is just we are cropping the image, but here we have to be sure with the size of the cropping if it's keeping the same class or not. For example, in the left image here, when we make this cropping, it's still cat, so the label it will be the same. If the cropping only cutting the head, again it's still a cat. But if we make random cropping and then it comes only to this white corner, so for sure the class it will be changed. So we have to be sure when we are making cropping what we are cropping exactly. Now the random cropping method also it's available in TensorFlow.image class, and it also comes with the size. That means the result of cropping, which size you want to be. In general, we are not using the random cropping alone. Why? Because consider that we have an image of 25, 255 with 255, and then we crop it and we want to make it again 255 to 255. So we are going to expand the image with some random pixels. And for sure, in our use case, we are not going to use kind of deep fake just to generate the pixels here. So
real quick, guys.
Yes.
Tirth, did you feel like your question was answered, Tirth? So Tirth was asking earlier, this is just for one line on the flipping. No, it is basically all pixels across the center line according to your flip direction.
Oh, okay. But I didn't get the question in correct way, but yes, let's say if we have image 9 by 9 and we want to make the flipping, so according to the algorithm that we mentioned, we have one center column in that matrix. It will not be touched. It will be the same value because we are flipping on the left to the right. So this is how. So let's say I will back to the question later. But for the cropping, we are in general used something else before. We use resize with the crop or pad. This method will give us the same image with resizing, and resizing in general, sometimes we add let's say kind of margin for padding. And after that, we make the random crop. So we will be sure that the final image, it will be from the same size of the data size that we have, the data set that we resize according to them. Okay, so this is how to use the random crab. The other thing, it's it's the rotation. And rotation here in TensorFlow, we have this method called rot90, and it's make 90 degree rotation, and we can call it multiple times to get 90, 180, 270, and again 360, 360, which is the same original. So one of the method, it's also sometimes to use rotation, but here's one of the question in our assignment today. I will ask it right now. What if I need to rotate for 15 degree or 20 degree only? I don't want to use 90 degree rotation. I want a small rotation only, because the 90 degree rotation, it will change the image totally. And the coming slide, it will tell us one of these scenarios, how it's only small rotation, it will help me, not flipping, not mirroring, not flipping, and not cropping, sometimes not cropping, okay? Which is this one. Let's say we have X-ray images, and in this chest X-ray, we have this side, it's little bit lighter in color because here it's the heart, which is on the left side of the image. Now, if I make a mirroring, let's say I'm trying to discover if this patient has COVID or SARS or any other disease related to the COVID family, COVID virus family. Okay. Now, if I make flipping to make data augmentation for my task, I will get the heart on the right, which is totally a new medical finding. It's not part of the scope in my discussion. So flipping here, it's not helping. Let's try, even if we think that we make a 90 degree rotation. Also, it will not help. Only it's acceptable to have 15 degree to 20 degree maybe. So the image, it's a little bit not 100% vertical. This is acceptable. This case we might face, but we cannot face a patient on different side. That this is what we have. So sometimes we have to be sure if our data augmentation techniques, it will be useful or not, because sometimes it will not be helpful at all. Now, by the way,
so
yes,
Guy, real quick, in this case, I agree. Flipping and rotation would actually unnecessarily train the network. It would even erroneously train it. But at the same time, I would think we would only need slight cropping,
yes,
because the techs are pretty good at taking these pictures, but there can be some shifting in the image. But we wouldn't need to do large scale cropping, correct?
Yes, the cropping here is important because sometimes the text, it's a playing main role when we try to train neural network for this task, which is COVID. Sometimes we have the same patient with multiple X-rays. So when we try to make to use XAI for the results, we find that the name of the patient on the text here, it's playing the main role for deciding if it's COVID. So according to that, yes, crabbing here, it will be very useful. So depending on how to crab it also, but at the end, yes, but flipping and rotating, it's not, even if we are going to use rotate it, we have to be very careful about how many degree it will be. Okay, so one of the tasks is to check or to find a way to rotate with 15 degree or 20 degree. That means with a degree as a parameter, not something fixed, it's 90 degree. Okay, now another method we are able to use it for data augmentation and for other tasks, in fact. It's not only data augmentation, it's the grayscale. It's moving the colored picture to grayscale picture. Now, what is the grayscale picture? In fact, it's the same picture, but the three channels, which is the red and the green and the blue, for a specific pixel, they have the same value. That means the red value equal to the green value equal to the blue value. when we did that, we are able to use only one channel to represent the image because it will be in this side. So moving from here to there, it's kind of just unifying for each pixel the values of the three channels. Now, one of the methods to do that, it's all just make the average. That means for specific pixel, go ahead and make a sum for the three values for blue, green, red, and then divide it by 3, and you will get the unified value. But according to the image processing people or scientists, they find that the best grayscale, it's having these parameters. That means you have to get 0.31 from red plus to 0.52 from green, which is the green. It's playing the main or the most important role here in this, plus 0.17 for the blue. When we did that, we are able to get a grayscale image. And by the way, the early algorithms for face detection and face recognition, it was using not only grayscale, even binary images, which is 0 or 1 only, the value in the pixel, but using the clustering. So moving from color to grayscale, it's very popular routine that we will face it like. For sure, in TensorFlow, we have RGB to grayscale image, which is return to us one image with one channel, which is the grayscale. We will be passing image with the 3 channels. That means it's red, green, and blue, but the output, it will be one channel image. Now, in TensorFlow also, there is something else called grayscale to RGB. Now, what is
Now,
this?
real quick, Brother Guy, there's a question. Is there a reason why one would choose grayscale over color? And I thought it'd be interesting to let a student try to answer that first, and then we can back it up.
Anybody want to answer?
Now, Avinash actually gave the first answer in the chat. By the way, just to add, grayscale is only useful where we don't have anything to do with color information. Cases where we need to track the color, like object tracking, there the color is useful. So you have to ask the question for your use case. Do I need color here? Do I not? So if you're just looking for features that are structural, why do you need color? But if there's important information in the color, then try to retain the color. Why would we want to go to grayscale though, when we don't need color? Well, I'm going to just answer it for time's sake. Training speed. We just reduced the volume of the data by 1/3 or to 1/3 of the original. So it's huge help.
Exactly, this is the main target. And also, we can use sometimes the grayscale as data augmenting method. Add the same images with the grayscale. If it's not losing that means anything you can make it to the image, you can use it as data augmentation. But the most important is the training speed and the cost of this training, because here we are using only 1/3 of the original images. That means 1/3 of the original data set. Now, in TensorFlow, we have a grayscale to RGB. What is this? What is doing? It's coloring the image. In fact, no, it's only repeating the same image to 3 channels, the same values to 3 channels. That means it stay grayscale, but it's make it to help us to make some other calculations or to use this. So let's make it as 3 channels. And here is our second question for the assignment. Is it possible to find a way to color a grayscale image according to the information that it's already on the slides? So this is our second question. Now, another method for data augmenting is the color shifting. And here is a clear example about the color shifting. Again, we have to understand that we have the image of 3 channels. We have 1 channel for the red, 1 channel for the green, 1 channel for the blue. Now, if I add some fixed value, and this is also one of the hyperparameters for sometime for your task. What is the value for that color shift? If we add fixed value to one channel and we reduce it from another channel and add it to the third channel, for example, we add to the red channel always 20 for the pixels. And in the green, we make it less by 20. And again, in the blue, we added extra 30. We will have a picture has the same features, but a little bit just like you drop a blue ink over it, for example. So this kind of color shifting, if it's not losing the features, it will be helpful for the data augmentation. And when it will be used, especially when you know that the original data set, it has a kind of shifting from normal coloring. So sometimes you get a data set that it's already has a blue shifting or green shifting. So according to that, making this color shifting, it will make a correction for your data set, and also it will be helpful for the data augmentation. Now, this is the most popular data augmentation method we want to speak about. There is something, it's very nice, it's very useful, which is the BCA color augmentation. We are not going to discuss it right now. We have to discuss about the BCA first. So we'll keep it for future, but I noticed it here because when we reach it, this method, it's on the Alexanet paper. It's discussed in details, and there is some free, that mean open source implementation for it, but it's really nice thing to do. It's complicated, but very nice. But we have to first know what is the BCA and discuss about the BCA and where it's used, principal component analysis. So this will come in the future. This is my discussion for today. By the way, I'm sorry for the practical part. I'm just going to show you that it's already, we have something here that helpful for the data augmentation, which is in this. By the way, this is the problem, Tom, that we face it. Okay, I'm losing the. Sorry. Okay, here we already in our malaria data set, we have a method. I didn't. This is. I'm sorry for that because I didn't push it yet to the GitHub. We have already a method called. Sorry, the before trained model augment data. Baba, hello, this is my daughter trying to share her idea. Okay, this one. Resize and risk.
Guy,
Okay,
could you
the augment.
Real quick, Guy.
Yes.
Principal component analysis applied to the images. Help us understand the motivation to apply PCA to the images. I think that would help more than just me.
But is it possible to push it for another day?
Yes.
Because we need to discuss it in details.
Yes.
And
no,
the
that is
BCA
fine.
already we didn't discuss it here. Okay.
Can I add something quickly regarding the PCA? Guys.
What are you asking, Avinash?
Hello. No, I'm saying, can I add my views on the PCA regarding the images?
Let's hear your views the next time that Guy addresses this. I was not appreciating the fact that he has some more material to get through, but don't let us forget, Avinash, okay?
Yeah, sure.
It looks like we might have lost Geith to a freeze. Yes, we did. Oh, I'm glad he made someone a co-presenter. So we did. We'll wait for him to rejoin. Avinash, I guess you and I could talk about PCA, but I will give a brief intro to why I think it could be important to use it. Think of the colors as being features in a way. And you do PCA on the images to see, well, which colors, and by the way, I could be wrong on this, I'm making an educated guess, which colors are most helpful in this, or which blend of colors. And then you could adjust. There he is. I will stop now. Go ahead, Guy. We don't have your audio right now. Oh, you're muted is all. Excellent.
Please continue, Tom. Continue.
Well, it was a bit of a wild guess, but we were just talking about why we might use PCA in the images. And I was just saying it may be to figure out how which colors channels are the most predominant so that we in fact highlight the information better, but I wasn't sure.
Exactly what you are saying, and this is why we can decide which color it's need to make shifting for it according to the BCI analysis, something like that. So at the end, we are doing that color shifting, but using the BCA. But the details, it's need to be separate sessions. So that's why I prefer to keep it for later. Now, I'm sorry, I have problem in the connection. Also, that's why I lose everyone. But I just want to be sure that, okay. Okay, I think we lose the YouTube also. Okay,